In this video, I would like to discuss with you about decoder and encoder. Decoder is a logic circuit in which we have n inputs and 2 raised to n outputs. That is binary decoder. Encoder is a logic circuit in which we have 2 raised to n inputs and n outputs. First of all, decoder. Decoder is a combination circuit that has n input lines and maximum of 2 raised to n output lines. This is a block diagram of decoder in which we have n input lines and 2 raised to n output lines. The name decoder means to translate or decode coded information from one format to another. A binary decoder is a logic circuit in which we have n inputs and 2 raised to n unique output lines. Binary decoders are 2-bit, 3-bit or 4-bit codes depending upon the number of data input lines. If a binary decoder receives n inputs, it actives only one of its 2 raised to n outputs based on that input, and all other outputs get deactivated. This is 2 to 4 decoder in which we have 2 input lines A0, A1 and output lines Y0, Y1, Y2, Y3, 2 raised to n, that is 4. And we have a chip enable signal E. This is the truth table of 2 to 4 decoder in which we have 2 inputs A0, A1, outputs Y0, Y1, Y2 and Y3. And remember, E should be high in order to get outputs. First case, when A0 is equal to 0 and A1 is equal to 0, we get high at Y0. When A0 is equal to 1 and A1 is equal to 0, we get a high at Y1. When A0 is equal to 0 and A1 is equal to 1, we get output at Y2. When A0 is equal to 1 and A1 is equal to 1, we get a high at Y3. This is the Boolean function for the output. Y0 is equal to E into A1 dash into A0 dash. Second, Y1 is equal to E into A1 dash into A0. Y2 is equal to E into A1 into A0 dash. Y3 is equal to E into A1 into A0. This is the logic circuit for 2 to 4 decoder, which is same as that of 1 to 4 demultiplexer. Let us see. This is the logic diagram of 1 to 4 demultiplexer. Instead of data line, here we have a chip enabled signal, and instead of control lines, we have inputs. So we are swapping this control line and data here. We have a chip enable here instead of this D, and we have a A0 and A1 instead of our control signals. When A0 is equal to 0 and A1 is equal to 0, A0 goes through this NOT gate. So here it is high. Here also it is high. This is high. Therefore, Y0 is high. In all other case, any one of the input will be low. The second case, when A0 is equal to 1, it comes here. A1 is equal to 0, goes through NOT gate, therefore 1 here, E1. Therefore, this AND gate get activated and all other AND gates get disabled. Like that, we can check 2 other combinations too. Encoder. Encoder is a logic circuit which performs the reverse operation of decoder. That means It has 2 raised to n input lines and n output lines. Therefore, encoder encodes 2 raised to n input lines with n bits. 4-to-2 encoder. 4-to-2 encoder is a logic circuit in which we have 4 inputs and 2 outputs. Inputs are Y0, Y1, Y2, Y3 and outputs A0, A1. This is the truth table of 4-to-2 encoder in which we have 4 inputs and 2 outputs. This is the logic diagram in which when Y0 is equal to 1 or 0, we get 0 here because we are not connecting Y0 here. Therefore, output will be 0, 0. Next, when Y1 is high, we get a high at A0 because Y1 is connected only to this OR gate. A0 is high, A1 is low. Second case, Y2. When Y2 is high, we get high here. A1 is equal to 1. It is connected only to first OR gate. Therefore, A0 is 0. Last case, when Y3 is high, Y3 is connected to both OR gates. Therefore, A0 is high, A1 is high. Therefore, 1, 1. This is the logic diagram of 4-to-2 encoder. Second encoder is decimal to BCD encoder, in which we have decimal numbers at the input and output is binary coded decimal. So that we have 10 input lines and 4 output lines. Each input line corresponds to 4-bit binary coded decimal. This is the truth table of decimal to BCD encoder, in which inputs are 0, 1, 2, 3 up to 9, 10 digits. Then binary coded decimal, we can see the weight 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. 0 means 0, 0, 0, 0, 1, 0, 0, 0, 1, like that, 9, 1, 0, 0, 1. If we consider 8421 format, we can easily understand this truth table. This is the logic diagram for decimal to binary coded encoder, in which we have inputs 1, 2 up to 9, outputs A0, A1, A2, A3. Remember, A0 is the least significant bit, this one, and A3 is most significant bit, this one. So, when I give a high or plus VCC to 1, this OR gate get activated and we get an output 1 here, then all others 0. So, for 1, 0, 0, 0, 1. When I connect 2, this OR gate get activated. Therefore, here 1, all others 0, 1. We can take 5. If we consider 5, this OR gate get activated. Same time, this OR gate also get activated. Therefore, here 1, here 1. 0, 1, 0, 1. 5, 0, 1, 0, 1. 8. When I give high at this 8, we get 1 here, 0, 0, 0, 1, 0, 0, 0. Then 9, 1, 0, 0, 1. When I connect a high at 9, this OR gate get activated and the first OR gate also get activated because 9 is connected to both OR gates. Therefore, 1, 0, 0, 1. Therefore, our output is 1, 0, 0, 1. This is decimal to BCD encoder, in which input lines are decimal digits and output is corresponding binary coded decimal. When I give high here, output is 0001. 2, output is 0010. 3, output is 0011. This is most significant bit and this is least significant bit. Next 4, 0100. 5, 0101. 6, 0110. 7, 0111. 8, 1000. 9, 1001. And this is the logic expression for outputs A0, A1, A2, A3. Thank you for listening. Have a nice day. Thank you.